solution, then we opt to the numerical solution. Okay, we go to the numerical solution. In the case of analytical or exact solution is not available, then we use the numerical approach, numerical methods. Okay, so you may have a problem where you cannot differentiate the equation, you cannot integrate the equation, it is not solvable, then we need to think of numerical. Okay, so when we're talking about numerical methods, okay, you actually get the approximation solution. Okay, what you have in DE is the exact equation. What you have in a numerical approach is called the approximation solution. So of course, when you compare between analytical and numerical, that will be error. Okay, the difference between the exact and numerical approach. Okay, so if you can see here in the weekly schedule here, okay, example here you have the numerical differentiation. So you use the numerical approach to solve the differential equation. Okay, but in this topic here, we are not dealing with the equation, but rather the data. Okay, the same thing, integration. How do we solve the integration using numerical approach? Okay, ODE. This is what you have before in chapter 1 and also chapter 2. Okay, but no more separation of variables, no more, what do you have before, exact equation, Bernoulli, no more. Okay, so we are going to use numerical approach to solve those equations. All right, okay, you have to get the BBP, the initial value problem, boundary value problem, and this is your last topic in DE before, also last topic in our syllabus now. Okay, so this one. Okay, if you can recall, if it is ring the bell. Okay, wave equation, heat equation, Laplace and Poisson. Okay, so basically slightly same problem but different approach. Okay, numerical approach. So that's on the weekly schedule, and for the textbook, the main reference would be this one, the textbook, okay, written by Cik Rahim Cik Teh, Numerical Methods with MATLAB Programming. So if you already have this book, okay, just use it. Okay, no need to get a new version, basically the same one. So if you plan to buy this book, I'll share later the contact number of Encik Rahim, okay, because you are at home, so the author basically will post out to your home. Okay, so I'll share the contact number so you can deal directly, okay, with Encik Rahim. Okay, I'll put in the group after this. Okay, that's on the course outline. Okay, anything you want to ask? So normally student wants to know when is the test. Okay, when it is test 1 and test 2, also the distribution of marks. Other than that, I think students just keep this course information. Okay, so if you know any of the lecturer here, and you can contact them as well if you prefer. Okay, so I don't mind. Okay, with that. Okay, ada soalan on the course information. Okay, boleh. If you don't have questions, then we may proceed directly to the lecture lah. Yes, so I hope you have your lecture notes ready. Okay.
Boleh, Doktor.
Aman kita tak ada. Okay, good. So I'm going to share the PDF now. Can you see the draw board dekat situ? Okay, boleh. Alright. Okay, so the first chapter is on root finding. Root finding. So what the scope of this chapter is actually to get the roots of a non-linear, non-linear equation. We are dealing with the non-linear equation because if we're talking about linear equation, dia senang. It is quite easy to get the root of a linear equation. Okay, so we specifically want to get the root of non-linear equation because of its complexity. So dia susah sikit lah compared to the linear equation. Okay, so our scope is just on the non-linear equation. Okay, finding of non-linear equation. There's a word of wisdom here. If you cannot do great things, then do small things in a great way. Okay, so kita selalu dengar, kalau tak boleh buat semua, jangan tinggal semua. Okay, buat apa yang kita fokus, apa yang kita boleh buat itu walaupun itu adalah kecil. Okay, if it can give you big impact, walaupun even though it is small work, small thing, tapi if you focus on that, if you successfully buat the small thing itu successful, so dia akan jadi besar juga. Okay, so just word of wisdom. So basically the contents not that much in the first chapter. Okay, we will start with the introduction of what is the root finding, and then the important theorem that we need to know, the IBT, and then the methods. Okay, so the three methods that we are going to discuss, okay, are the bisection, Newton-Raphson, and fixed point. Okay, fixed point iteration method. Okay, so first. Okay, by looking at this graph, okay, stated over there, roots of y equals x squared minus 4 or x equals -2 and x equals 2. So how do you explain that x equals -2 and x equals 2 are basically the roots of x squared minus 4? So how do you tell to, how do you explain to anyone, okay, that by looking at this graph that x equals -2 and x equals 2 are actually the roots? Why do you say that x equals -2 and x equals 2 are the roots of x squared minus 4? Anyone? Anyone respond? How do you explain, let's say, to your Form 3 sister or brother? How do you explain by looking at the graph? Okay, the roots of that equation is actually -2 and 2. So then your sister or your brother will ask, how will you know? How do you know? By looking at the graph. Macam mana nak beritahu? Yeah, intersection. So Zuhaimi, yes, the intersection at x. So basically, if you have read or looked at your lecture notes, I've stated over there the roots of a given function. Okay, if it is in terms of graph, okay, by looking at the graph, it is actually marked by the intersection. Okay, intersection points between the curve. Okay, the green curve here with the x-axis. Okay, so we have this point. Okay, x equals 2 and x equals -2. So the intersection points between the curve and the x-axis. Okay, can you see? Boleh nampak tak kecil sangat because I cannot write if I zoom in. Okay. Alright. So that one is by looking at the graph. Okay, if you don't know what is a graph, okay, I just telling you that the roots of y equals x squared minus 4 is -2 and 2. So how would you prove that? Katakan tak ada no graph. no graph. So I'm just telling you the roots of x squared minus 4 are negative 2 and 2.
When we change the x to negative 2 and 2, y is equal to 0.
Yeah. Okay. So the value of x, the roots of that equation, which is negative 2 and 2, when you plug in into the equation will be 0. It means that you are satisfying the equation. Okay, so itu maksud dia. Okay, so what I have written here, in other words, we want to solve fx equal to 0 for x in the case of this one. Okay, analytical solutions available. Okay, so maksudnya when you replace x equals negative 2 and x equals 2 in this equation, you will get y equal to 0. Okay, or in other case, we normally use the notation of f. Okay, so that proves the root of given equation. Okay, but in terms of numerical calculation, okay, in terms of numerical solution, when you plug in the value into the f or into the y, most likely the answer will not be exactly 0. Because of what? Again, uh, normally in the numerical approach, okay, you round off your result. Okay, you run off to 4 decimal places, 3 decimal places. Okay, so at the end, when you plug in the value of x, okay, then fx will not be exactly 0, but it should be close enough to 0. Okay, so for example, later you use the bisection method to find the roots of x squared minus 4 here. Okay, so most likely your final answer will not be exactly negative 2, but it could be negative 2.005, for example. Okay, because of the round off, okay, in your calculation. Okay, so when you put back in the equation of y here, so of course y will not be exactly 0. Okay, but should be close enough to 0. Okay, that's what we call the error of the solution because of the numerical results. Okay, so again, okay, so look at this paragraph here. Based on figure 1.1, okay, we can roughly say that the roots of y equals x squared minus 4 lie between the interval negative 4 to 0 and 0 to 4. Okay, so maybe, okay, without the graph, so I'm just, let's say someone tell you that the root of x squared minus 4, I don't know what is the root of x squared minus 4, but I can assure you that the roots are going to be in the interval negative 4 to 0, one root over there, and the second root would be in the interval 0 to 4. Okay, so how do we prove that statement? Okay, so this is where we use the IVT, the intermediate value theorem. So basically, we use the IVT to prove the existence of the root. Okay, so you can imagine like this: you have the nonlinear equation. Okay, you don't know yet what are the roots. Okay, it can be 1, it can be 2, it can be 3, depends on the polynomial that you have, depends on the equation that you have. You don't know yet what are the exact solution to that, what are the roots, but you can predict what is the interval, okay, of where your roots are going to be. Okay, so for this one, I can roughly say by looking at this graph. Okay, so you can imagine that you don't know this one. Okay, don't know, but I can simply say the root is going to be in the interval negative 4 to 0, which is true lah kalau you refer to the graph. Okay, so because negative 2 is between negative 4 to 0 and 2 is between 0 to 4. So now the question is, how do we come up with this? How do we prove that the given interval is true? Okay, because sometimes you don't know in real application. Okay, in assignment, most likely you were not given the interval. but in order to start the calculation, you need to guess. You need to guess your own interval. So how would you come out with the number? Mana satu, apa from negative infinity to positive infinity, what are the possible number to be considered as your interval? Okay, it could be -10 to 0, but how would you prove that -10 to 0 is the correct interval where your solution would be? Okay, so the proving would be the IVT. Okay, the IVT says that, okay, if f is a continuous function, okay, in our case is the nonlinear equation defined in the interval a to b. So I need to highlight here the words continuous function. It need to be continuous, okay, in the interval a to b. So if we can prove that fa times fp is negative, which is less than 0 lah, okay, then we can say that, okay, you are going to have the interval as the interval in A and B. Okay, so keywords dia ada 3 for the IBT. So you need to state the word continuous. Yang kedua, number 2, FA times FB is less than 0. Okay, and number 3, dia punya conclusion lah. Therefore, there exists a root lah. So the definition of IBT should consist of those 3. Okay, those 3 keywords lah. Okay, this is quite common to be asked in the test. Okay, state the intermediate value theorem ataupun you kena prove dulu before you start the calculation. The question asks you to prove the interval lah, the correctness of the interval. Okay, so you need to refer to this. Okay, the IBT, intermediate value theorem. Okay, let's see the example here. Okay, use IVT to verify that x power of 5 blah 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 equal to 0 has a solution on the interval 0 to 1. Okay, so A is 0. Okay, kasi saya nampak A equal to 0, B equals 1. Okay, so corresponding F, okay, correspond to A equal to 0 is F0, which is -1. So basically just plug in x equal to 0 in this equation. Okay, so tekanlah calculator, use your calculator, blah blah blah. So you get f equals -1. And the second one, b equals 1. Okay, the corresponding f would be f1. So change, x now becomes 1. So tekan calculator, so your f is 1. So you can see when you multiply this, okay, f1, f0 times f1, then you get negative value in this case because one of the signs is negative. Okay, so f0 is negative, f1 is positive. So when you multiply, you get negative, which is, okay, less than 0. So we say that there exists root in the interval 0 to 1. Okay, so I want you to highlight this part here. So when you multiply, you are actually just looking for the sign. You are not really want to know what is the exact value of f0 times f1. Okay, you just want to know the sign. So basically, you just look for the sign f0 and f1. Okay, if one of the value is negative, okay, then you get the negative value. Okay, so you just take like that. Okay, so don't need to write the -1 times 1 equals -1, no need. Okay, no need to do this in the test or in the exam. Okay, you just write this way. F0 times f1. Okay, it's just okay, just looking by at the sign, so you know it is negative. Okay, but lastly, you need to write down here because I've mentioned just now. Okay, this one, the statement, the conclusion here need to be, okay, in the solution. Okay, so the 3 keywords just now. Okay, as is the solution. So if you just stop up to this, okay, up to this one, then you will not get the full mark. Okay, it needs to be the final conclusion here, because we want to know. Okay, if you get the negative value, then what? Okay, or in contrast, if you have the positive value, then what is your conclusion? Okay, so we want to know what is your conclusion. Okay, sometimes I can understand that students know that. Okay, but you need to show on the paper. You need to prove on the paper your understanding on the IVT. Okay, so please highlight that one. Okay, need to have the conclusion. Okay, so just write. So sometimes students just write this one. After this, after less than 0, then you can simply say, therefore, x asterisk here basically refers to the root. Okay, so you can use that notation. Is in the interval 0 to 1. That's it. Okay, so find FA, find FB, look for the sign when you multiply those two, and write down your conclusion. That's it. Okay, ada soalan? Any problem? Yes, 9, IVT. So in exercise 1 ni, state what is the intermediate value theorem. I just write one more time. So these are the things that you need to have in your sentence. Okay, I don't mind. You just use your own words, but it should be, it should consist of these three keywords: continuous, and together with the continuous must be also A and B lah, the interval. So if you use um, C and D, then change accordingly lah. But normally student will stick to the common way to write the interval A and B. So second one, FA times FB need to be negative, and lastly the conclusion as is a root lah in A and B. Okay. So macam mana nak tulis tu, terpulang macam mana you nak ulah ayat. Okay, supaya you senang faham. As long as it contains those three keywords lah. Okay, so you might want to write for a continuous function fx in the interval a to b, okay, comma, if fx times fb is less than 0, then there exists a root in the interval a and b. Okay, boleh buat macam tu. Okay, if you nak ikut definition, if you want to follow the definition 1.2.1 tu pun boleh juga. Okay, ada soalan on the IVT? Try on your own now, exercise 2. Check which one is the correct interval. 1 minute. Interval 1 or interval 2 should consist the root of sine 2x plus x cubed minus 3. Okay, buat sekarang. If you have any questions, you can ask in the chat room, or you can simply talk on. Azim, okay Azim?
Okay, tu.
Okay. Kira buat calculation. Yeah, which one? Number 1. Is that the correct interval? 0, 1. Aina Nabila. Dah buat calculation. Aina ada Aina. Zati. Amira Zati. Mana semua ni?
Sebab kosong kira betul.
Tengah kira.
Oh, tengah kira.
Okay, I forgot to mention, in your calculator, whenever you have the transcendental function ataupun trigonometric function, guna radian mode use radian mode. Or to be safe, for numerical methods ni, just change your calculator mode to radian lah. Okay, always be safe macam tu. Sebab nilai X tu diberi, dia tak ada tanda degree pun dekat situ. Okay. So guna radian. Okay, boleh tulis dekat chat room tu root mana yang betul, 1 or 2. Okay, root 2 pula interval 2 okay. So okay. Okay, so for the first one tu, your F0, because your A is 0 kan, so F0 should be -3.
Betul.
F1 should be -1.091. Okay, so you have both are negative. Hidup tepi jalan ke apa? Macam motor je. So F0 times F1 is positive value lah for the first one. So it is not negative. So we conclude that there's no root lah in 0 and 1. Okay. So for number 2, F1 is negative. Okay. And F2 is 4 point something, which is positive. So when you multiply, so that's why we dapat negative value lah. Okay. So you conclude there's a root in 1 and 2. Okay, so for exercise 2 ni jawapan dia 1 and 2. Okay, root dia 1 and 2. So that's on the IBT. Now, we go to the method. Okay, so just now we just find the interval. We just verify the interval sahaja. Okay, so now we want to know the root value itulah. Okay, the value of x that satisfies your non-linear equation tadi. Okay, so basically we can categorize methods that we have in this topic into 2 categories lah. Okay, so the first one is the bracketing method. We only have the bisection, but in the textbook, in the reference book, okay, ada banyak lagi. There are many more in the bracketing method. Okay, but in the syllabus we just cover the bisection. Okay, and in the open method we have 2, Newton-Raphson and fixed point iteration. Okay, so for the bracketing, it is called the bracketing method because in order to start the bisection here, we need to have the interval left and right. So that's why kita namakan dia bracketing method, because you bracketed your solution to into left limit and right limit lah. So bracketing method. While in the open method, you don't really need the interval A and B lah. So you just need to have the initial guess. Okay, initial value of your x, denote by x naught. Okay, so satu value dekat sini. Okay, so I can write E lah. Okay, so itu beza bracketing method and open method. Okay, so look at the bisection. So if we're talking about bisection, it means 2 sections. The word bi means 2. Okay, so you have section, you divide into 2, then we call it bisection. Okay, so the analogy to the bisection, if I can put this way, okay, if if you can grab the concept dia lah, analogy dia. So for example, you have a dictionary from A to Z. Okay, so saya tulis kat sini. So A to Z. You want to find one word, the meaning of one word start from T, for example. Any word lah, susah nak tak tahu apa maksud dia. Okay, so you have the dictionary on your own. Okay, so in your mind, you want to know the meaning of a word. Okay, certain words start from T. So you are not going to flip one by one, page by page from A. Okay, so you will waste your time. So the idea is to flip your dictionary into two. Okay, so you can imagine you have one section, A to Z, you flip into two sections, the bisection just now. So on your left, you have, okay, so let's say when you flip, okay, so you can see on your left, you have M words. So you know that on your left hand side, it is from A to M, right? And then on your right, okay, most likely it's also M lah. Okay, but you know on your right it is M to Z. And in your mind, you want to know the word T. Okay, so in the next flipping, you want to decide whether you want to consider your left section or right section, knowing that in your mind you have T. Okay, so since you stop at M, then most likely you will choose your right section. So now you will consider M to Z on your right. So you will flip again into two. Okay, so in the second flipping, so if you see at left hand side, okay, you have M to Y, for example. So you know on your right hand side it is Y to Z. Okay, but in your head you have T. So in the third flipping, you will consider your left section now, because you know T is in the left section. Okay, so you're clear on that. So that's the analogy of bisection. From A to Z, you narrow down to M to Z, and then in the third flipping, you narrow down, okay, until you find out the T. Okay, you will stop when you flip, then you see the word that you wish to get. Then you know that you have to stop flipping. Okay, so that's the idea of bisection. Okay, you have one big interval, you cut into two, then in the next iteration, which is the flipping just now, you want to decide whether you want to choose the left section or the right section, and you start calculate again. So in the next process, you cut into two again. Okay, so you are narrow down your interval until finally you comes down to your solution. Okay, that's the analogy of the bisection. Okay, so now look at this algorithm here. Okay, the process of dividing your dictionary just now into two is illustrated by the C here. C is A plus B over 2. So you divide into two sections. Okay, and then number 3 here actually illustrate the decision whether you want to choose left section or right section just now. Okay, so it is given here. So in terms of bisection method, if FA times FC is negative number, then okay, you choose or you change your B. Okay, you change your B. If FA times FC is greater, which is positive, then A need to be changed. Okay, so the decision tadi, yang saya cerita tadi, choose whether left or right hand side is actually illustrated here. I will explain mathematically here. Okay, after this. And then the process, the stopping condition is given here. Okay, just now in the analogy of dictionary, when you see the words that you wish to get the meaning, then you stop. but mathematically in bisection, it needs to have the stopping condition now. Okay, because this is iteration process. Iteration meaning you keep repeating the same process. So you need to know when do I need to stop. So it must be condition where I need to stop. So these are the conditions. Okay, so it should be stated clearly in the questions lah. One of these. Okay, one of these. If it is not stated, then any of these conditions, okay, which one that you see first, okay, you can stop directly. But normally in the test, okay, so to avoid varieties of answer, so normally we will state which one, okay, which one or out of these three. Okay, so this is the stopping condition for a given tolerance error. So the epsilon here should be given, should be stated. And finally, we write our solution. Okay, so the last one here is normally what student miss to write. Okay, common mistake ni. So tolong highlight itu method. Okay, the student do the calculation, but at the end forgot to write down the conclusion, because your process here is actually trying to get value of x. Okay, that satisfies your equation. Okay, given the fx, so you want to know what is the equation, or what is the value of x basically. So at the end, you must write down what is the value of x, okay, which is approximated to the last value of c. Okay, another common mistake, students tend to write jawapan akhir itu approximated to fc, which is not true. Okay, because if you can recall the graph tadi, the roots are basically on the x-axis, so it must be the value of x lah. Okay, so x refers to A, B dengan C in your calculation sebab dia atas x-axis. So the value of f is basically at the y-axis, so dia bukan root. Okay, so dia adalah corresponding value of f bila nilai x sekian-sekian. Okay, so ini algorithm. Okay, so I'll show you, I'll explain more, okay, in this example. So please write on your own. Please read on your own for the advantages and disadvantages. Sometimes for 1 mark questions, okay, kita tanya juga ni kadang-kadang. Okay, so read on your own. If you cannot understand, then you can refer to me later. Okay, now for the example 2. Okay, since you already have the solution in your notes, just focus to the explanation. Okay lagi tak tu? Okay. Alright. Use bisection method to determine the root of a nonlinear equation x cubed blah 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 in the interval 1 and 2. Stop the iteration. So ini yang saya kata tadi, the stopping condition must be stated clearly. Kalau tidak, macam-macam jawapan lah. Sebab ada 3 tadi, you have 3 stopping conditions. Okay, so mungkin akan ada few final answer lah kalau kita tak bagi yang mana satu the stopping condition. Okay, so it should be stated clearly together with the value of the epsilon. Okay, so yang tertinggal dekat sini adalah decimal number lah to use in the calculation. So normally in the exam we add one more, which is use 4 decimal places in the calculation macam tu. Okay, so okay, first iteration, I equal to 0. We start with the I equal to 0. So this is the first iteration. So our keyword, our B equals A plus B over 2. Middle point formula, simple je. Senang je nak ingat. Okay, so A not equals 1, our left interval, B not equals 2, okay, our right interval. So we compute C naught lah. Okay, and the corresponding value is 1.5. Okay, and then in the algorithm just now, first you calculate the C, and then you want to check the sign of FA times FC. Okay, because you want to decide in the next iteration what need to be changed. Okay, so we calculate FA, which is F1. Okay, FA ni, which is F1, so you get -2. And then FP, F1.5, so you get this value. Okay, so by looking at F1 times F1.5, so you can see it is positive lah, because both of the values of F are negative. So when you multiply, you have positive value. Okay, and then this is the stopping condition. You check for the absolute value. This is 0.875, way greater than the epsilon, the given epsilon. So jauh lagi, meaning that you need to proceed lah to the next iteration, I equals 1. But now, you want to know in the next iteration, okay, what is your next value of A, what is your next value of B. Okay, so I'm going to show you graphically here. So we have this graph. So just sketch saja lah. So your initial interval is 1 and then 2. Okay, scale may not be right, tapi it must at least common sense, make sense lah. Okay, you plot to must make sense. Okay, so on the y-axis should be the value of f lah. Okay, so when x is 1, which is your A, the corresponding f is -2. So itu point there. When x is, which is your B, the corresponding f is negative. Sorry, mana? Oh, ini salah. It's not negative. Betul lah, -2. Sorry, -2. When x equals 1.5, sorry, this one, 1.5, your value of C, and the corresponding f would be -0.875. Okay, so somewhere kat sini is 1.5. Okay, now okay, so I have the point 1, -2. So 1 is on the x-axis, okay, -2 on the y-axis. So dia should be at the bottom lah. Okay, so katalah dekat sini, somewhere here is -2. So ini this is the point 1 and -2. Okay, and one more point is 1.5, and the corresponding is -0.875. So it is also at the bottom. Okay, so somewhere dekat sini lah. Okay, -0.875. So dekat sini titik dia. Okay, so if we connect those two points and expand the lines, okay, the curve, since this is not linear, so you may want to have slightly a curve lah. Macam gitu. Okay, naik ke atas. So you can see now, the intersection is here. Yeah. Okay, if you can recall to the definition of the root just now, it is actually the intersection of the curve with the x-axis. Okay, so you have divided your interval 1 to 2 into left here, and this is the right. Okay, so since the intersection, okay, is denoted over there, so in the next iteration, you will use the right interval, the right section. Okay, so meaning that in the next iteration, your left limit would be 1.5. Your B remains lah 2. Okay, that's why we decide here, our conclusion here, in the next iteration, A1 is our C and B remains, because now we are considering the right hand side. If you see the intersection on the left side, okay, then your A would remain, your B need to be changed. It should change to the value of C that you have computed. Clear? Okay, so this is illustrated in the algorithm here. If FA times FC is a negative, then B change. This one. A remains. If FA times FC is positive value, then A change. Okay, so this one means you are taking the right, okay, the right interval, and this one you're taking the left interval. Okay, that's the decision. Okay, the illustration of FA times FC tadi lah. Okay, so if you can understand this um, concept here, the graphical explanation here, then okay, means that okay, basically you don't really need to memorize this one. Okay, if you can just plot here, okay, like this, then you can decide on your own here. Okay, what is the value of A and B in the next move, okay, in the next round. Okay, so in the next iteration we have I equals 1. Okay, the second repeat the same process. We divide into two sections. Okay, compute your new C would be 1.75 now. Okay, and find the FA, find the FC. Check the multiplication of those two. Okay, if it is positive, okay, check whether you need to change A or you need to change B. Okay, so this one in terms of diagram. Now we are considering 1.5 and 2. Okay, it is actually at the same location. I've just expand the scale a bit. Okay, 1.5 and 2. So in between, we have 1.75. Okay, so when x is 1.5, the corresponding is somewhere here, then negative 0.875. When x is 1.75, the corresponding is 0.2. So 0.2 is positive, so it should be at the top lah. So somewhere here. So when you connect this, so you will see the intersection is here now. Okay, so meaning that in the next iteration, you will consider the left section. So that's why okay, in the next iteration, okay, A remains as 1.5, but B change to be your current value of C. So you can see you actually narrow down. Initially you have 1 to 2, so you narrow down to 1.5 to 2, and in the next move you narrow down even more to 1.5 to 1.75. Okay, so you repeat the process until you satisfy the given stopping condition lah. Okay, so cut the story short, this is what we have. Okay, so dalam exam tak boleh lah nak dot je, lepas tu keluar jawapan akhir. No, cannot. So you must show this table at least. Okay, you can present your answer in terms of table only. Okay, acceptable. Okay, no need to write the manual calculation. Okay, so just have the table. But if you aware here, what I miss is the conclusion. Okay, so tambah last one. Therefore, your final answer should be the latest value of C. Remember, it should be the value of C, not A, not B, not FA, not FC. It should be the C. Okay, which iteration? I equals 6, which is 1.696. So that should be your answer. Okay, so that's it. So how do you check whether your answer is true or not? First of all, okay, you know the interval. Okay, the interval is given is 1 and 2. So your answer here is correct within the given interval. And you also can check, try to plug in 1.696 in the given equation. Okay, the answer will not be 0 because of the round off error here, but it should be close to 0 lah. Okay, if you put x equals 1.6 blah blah here in the equation and suddenly you get 2 point something, then salah lah tu. Okay, so it should be close to 0. Okay, ada soalan tak? Any problem? Questions? Nak tanya?
Doktor nak tanya,
Yeah.
benda proses ni kita akan ulang sampai kita dapat FCI tu lebih kecil daripada epsilon ke?
Betul. So you
Okay.
kena dekat sini lah, stopping condition dia dekat sini. Okay. So basically after you find the FC, you tengok stopping condition terus. Okay. Once you satisfy the condition, then you don't need to decide lah whether you want to change A or you want to change B. Okay. Kalau you tak meet the stopping condition, then you need to ask, okay, what is my next A, what is my next B. Okay, so every iteration check for the stopping condition. Okay, but sometimes you could have the stopping condition macam ni juga, so it depends on the problem lah. It depends on the equation. Okay, so you have 3 types of stopping condition just now. So please highlight which one in the exam, given in the problem. Okay, any more questions? Boleh faham bisection? Yes, it is true, quite tedious work lah bisection ni. Okay, dalam banyak-banyak method, I think bisection is the most tedious lah. Okay, sebab banyak kena kira. C, FA, FC. Okay, and the tips is if you didn't get your equation, your solution after more than 7 iteration, better you stop lah. Okay, check back your calculation. Okay, look back at your A and B lah. Okay, in case you switch the condition ke terlupa nak change A atau B. Okay, so kalau dah lebih tak converge lagi, mean you always get FC greater and greater, that is the sign when you need to stop lah. Okay, check balik daripada awal. So why the student losing marks in the numerical methods ni adalah because of the iteration process. Because basically the second iteration taking the result from the first iteration, and likewise lah for the fourth iteration, the sixth iteration and so on. So if you get the wrong answer in the first place, then everything's gone. Okay, so itu kenapa student hilang markas. Sometimes student come to the lecturer, say I can get the solution, jawab penuh. I get the final answer, tak ada tinggal kosong. Semua jawab, but I didn't get A, I didn't get B. So rupanya silapnya di situ. Semua jawapan penuh, but comes from the wrong answer. Comes from the wrong result. Itu not say difficulties, tapi something that you need to be very careful lah. Especially dalam kos-kos pengiraan macam ni, when it comes to the competition course lah. So itu under bisection. But there's a way to speed up your calculation actually by utilizing your calculator. So kita tak perlu kira satu-satu, masukkan value satu-satu dalam calculator. Okay, so in the exercise 3 there, I think we have time for one more example here, exercise 3. So I'm going to show you how do we speed up our calculation by using calculator. Okay, boleh Ada soalan lain ke? Any problem? Syafira, Syairah, ada soalan? You're in the same room ke tu? Lain-lain? Tak ada. Okay, good. Yeah, exercise 3. Okay, kalau physical class, kita boleh tengok Syairah dengan Syafira dia sedondon je. So missing that in online class ni. Okay. X square minus sin x plus minus 1. So highlight that. And then highlight your interval 1.4. Have the table ready. Okay, you boleh form your table macam kat atas tu. Stopping condition 0.005. Okay, answer is given for guideline. Okay, so we have mind you, my line. This is not actually a line. Ni bomba-bomba ni. Okay, so I, and then AI, BI, CI, FAI. Okay, get ready with your calculator. Okay, so sometimes kat sini I just put positive or negative. Yeah, yelah, betul. So always start with I equal to 0. Okay, so start dengan I equal to 0. And of course, the first value of A and B should be known lah, 1.4, 1.5. Okay, so normally for the first C, student boleh congak je dalam kepala. Because normally the initial interval nombor senang-senang je. Okay, 1, 2, macam tu. But as you go along the process, your value of A and B will be in terms of decimal number. Okay, so kalau contoh kat atas ni, dekat I equals 5 ni, nak congak C ni, tu kena dapat YU dulu. Okay, baru dapat 1.704 tu. So you rely very much on your calculator lah sebenarnya. Okay, so and then once you get your C, you also need to calculate your FA and also FC, which is referring to the equation x square minus sin x minus 1 here. Okay, so in your calculator, you actually, so I'm going to write down the equation that you are going to use in your calculator. So first, you will have C, which is A plus B over 2. And then number 2, your equation. So I'm going to write x squared sin x minus 1. Okay, so for whenever you change your A or your B, meaning that you also changing your value of C, meaning that the value of FA and FC may change accordingly lah. Okay, in the manual calculation, then you will press 1.5 square minus sin 1.5 minus 1 equal, okay, lepas tu dapat jawapan. When you change your x again, so you will repeat the same process. That will wasting our time. Okay, so now I'll show you. I think some of you may already know this from the previous or any other courses lah. So I'm just sharing the calculator view. Okay, nampak tak saya punya calculator?
Nampak, Doktor.
Okay, nampak Okay, ada tak yang guna calculator yang masuk tong sampah tu? Kalau ada yang guna tu, I don't have manual lah untuk tu, but you can explore lah. Okay, but it's very limited sikit dia punya features tu. Ada benda yang tak boleh. Okay, tak boleh dapat dengan cepat. Okay, so if you have the second type of calculator yang saya tunjuk dalam video tu, itu basically more or less similar to the class width ni lah. Okay, except that ada few lah yang class width ni lebih sikit. It can get the root of fourth order, I think fourth order equation, fourth order polynomial. You boleh check dia punya root dia up to fourth order. Yang calculator yang kedua tu up to third order saja. Okay, polynomial order 3 saja. Okay, if you want to solve linear system in chapter 2, so pun sama juga, calculator class width ni dia boleh up to 4x4, 4x4 matrix. Yang calculator kedua tu dia 3x3 lah item. Okay, so lebih sikit lah the class width. Okay, so terpulang lah. Kalau kebetulan you nak beli baru, so cari yang class width ni lah. Okay, tapi yang kedua tu boleh je pakai, tak ada masalah. Okay, so now so in your calculator, make sure radian mode. Okay, so first aim dekat sini is to store the first equation, C equals A plus B plus 2. So you have, kalau you tengok dekat sini, cursor nampak ke dekat ni, dekat calculator? Cursor saya nampak tak dekat calculator?
Nampak Doktor.
Nampak, okay.
Nampak Doktor, nampak.
Okay, so you have A, B, C, X, Y, F dekat sini in a pink ni. So kita guna alpha lah. Okay, sebab dia pink tu. So press alpha. So sebelum tu we may want to use the fraction dekat situ sebab kita ada fraction. Okay, ataupun boleh guna bracket lah kalau tak nak fraction. So alpha sini A plus alpha KB, okay, lepas tu kat bawah over 2. Okay, so press the equal now. So dapatlah, because I have the value of A and B before in my calculator, so saya dapatlah value ni. So it may be different, okay, with your values. Never mind. The purpose now here is just to store first. Okay, store the equation. Okay, so once you dah tekan the equal button tu, meaning that you have stored lah your equation. Okay, now press the AC button. Jangan switch off, do not switch off. If you switch off, then the equation tu akan hilang. Okay, AC okay. So now store the second equation, x square. So I'm going to use the x dekat sini. Ini x ni. So alpha x square minus sin, so alpha sekali x, so tutup bracket, minus 1. Okay, press the equal. Okay, so saya dah ada value x tu, so whatever value lah that you have. Okay, so now then, okay, so back to our table dekat sini. So first we want to get the value of C. Okay, so C comes from the first equation here. So now on your calculator, you press the up button dekat sini. So ini keluar equation yang latest, yang last kali, but we don't want this. We want the previous one, which is this one. Okay, so now you press the calculate button, this calculate button. Press the calculate button, and then your calculator will ask, what is your A? Okay, so I have previously, my A is 1.5, 1.4, which is what I want here. So if your current A is not this, then you need to press 1.4. Equal, then B is 1.5. So I press 1.5 here, so I get, this is the value of C. So change to decimal. So meaning that on your table here, so you just put 1.45. Okay, how about the F? So FA, okay, is referring to the equation number 2. So again, you go back to the equation, the second equation. Okay, use the arrow button, the up button here. Okay, find your equation. Again, use calculate button, press the calculate button, so the calculator will ask what is your x. Okay, so we want to get the corresponding f here when x is a, which is 1.4. So my x is, I press 1.4, so I have negative, okay, negative 0.0254. Okay, that is our FA. And FC, the same process. Now I press the calculate button one more time, but now my X is C, which is 1.45. Press the equal button. So 0.1098. Okay. So and then okay, along the process you check the stopping condition. Okay, so basically you look at the absolute value of this column. So this is positive 0.1098, way greater than the given epsilon here. So meaning that you need to um, repeat the process. Okay, proceed to the next iteration. But in the next iteration, we want to decide, okay, what need to be changed. Is it A or is it B? Okay, so again, it depends on the plotting here, or basically you refer to the algorithm here. If FA times FC is negative, then B change. If it is positive, then A change. Okay, so this one, FA times FB is negative. So you just put over the negative, the tolak. So in the next iteration, I equals 1, um, B change, B change. If it is negative, then B change, meaning that A remains as 1.44, B need to be changed to 1.45. Okay, so you have narrowed down your interval. Okay, but of course you need to get a new value of C lah. Okay, so go back to the calculator. Okay, so in your calculator, find the A plus B over 2. So now you press the calculate button. Your value of A is 1.4. Okay, the same one. And then, but you already changed your B. B is 1.45. So you have now a new value of C, 1.425. Okay, and FA, since A remains, meaning that FA also the same as previous, negative 0.0254, but FC is changed now because we have different value of C. So go back to the equation. So this, okay, this equation, but change your X. Your X now is 1.425. Okay, so it should be 0.0412, and check for the stopping condition. The absolute of FC is still way greater than 0.005. So we need to proceed with the iteration. Okay, so to decide which one need to be changed, we look for the sign FA times FC. So again, we have negative value here, meaning that B need to be changed. A remains 1.425. Okay, so if A remains at the first time, it doesn't mean it also remains in the next time. Okay, dia boleh change. Okay, switch saja. Okay, depends on the calculation of FA times C lah. Depends on the sign. Okay, so repeat the process. Ni tak banyak pun sebenarnya, 5 iteration saja. So you will finally stop at I equals 4. So I just give you the answer so you can fill on your own later. So look at me. Okay. So once you have satisfied the stopping condition, so tak sebenarnya tak perlulah nak check dah FA times FC. Okay, so you stop kat situ and look at the latest value of C. So it should be here 1.4094 lah as given in the answer. Okay, so tempat-tempat lain tu tolong penuhkan penuhkan. So you stop over that because this is already somewhere here less than the absolute ini less than 0.0. 05. Tinggal satu zero. Tak negative 0.0006. Okay, and don't forget, therefore, x asterisk is approximated to the last C that you have, which is C4, which is 1.4094. So itu jawapan akhir. Okay, boleh guna calculator ni. So in the exam, in the test, just have the form, have the table, fill up the table saja. So no need to write down the manual calculations. But be careful with the calculation sajalah. Okay. So dalam bentuk table ni, saya senang nak check lah dekat mana value yang start salah tu. Kalau salah lah. Ya, ada soalan? Satu lagi tu exercise 4, but I'll let you do on your own lah for exercise 4. Okay, ada soalan tak? Any problem on the bisection? Apa nak tanya? Okay.
Tak ada, doktor.
Ada. Okay. Nazir, okay Nazir?
Okay, doktor.
Okay. Okay. Muaz, okay Muaz. Faham Okay, so if you don't have anything, then I think saya tak proceed to Newton-Raphson lah, because it's going to be another hour lah for Newton-Raphson. Okay, so but if you don't have anything, I have one last thing that I want you to fill in or to respond. So saya sharekan the link dekat chatting ni, adalah feedback So itu adalah menti.com. Just give the feedback how you scale your understanding of today's topic. Okay, you can do it now or later lah, immediately after this. Sorry. Okay, baru letak untuk semua. Okay, dekat situ. Okay, so I'm going to stop sharing this one. I'm going to conclude what we have just now. Okay, so kita summarize balik what we have for today. So we have started with the IVT. So intermediate value theorem, again dia punya purpose dia adalah to verify the existence of the interval. Okay, to verify the existence of the root in the given interval. So how do we use the IVT? Okay, it should consist of the definition should consist of 3 keywords. Yang pertama, mesti ada word continuous. Okay, a function fx that we want to get the root must be continuous in the stated interval. Okay, so dia scenario dia macam ni. You punya equation tu mungkin dia tak continuous. Ada point where it is discontinuous, ada discontinuity point dalam equation itu. Tapi within the specific area, within the specific interval yang you consider, you kena make sure dia continuous. In general, kalau from negative infinity to positive infinity, it may contains the discontinuity points. Tapi when you ambil certain interval saja, A to B saja, you must make sure within that interval dia continuous. Okay, the IVT itu tadi must be continuous in the specific interval that you consider itulah. Okay, sebab in general mungkin equation tu ada discontinuity point, tapi discontinuity point tu out of range yang kita consider, mungkin keadaan dia macam tu, so it's okay. Okay, so continuous should be in the stated interval tu tadilah. Yang kedua, it should be FA times FB must be negative. Okay, negative value. Dan yang ketiga, the third point that you need to have in stating the IVT is the conclusion dia lah. If FA times FB is negative number, okay, is less than 0, then there exists a solution or there exists a root in A and B. Jangan stop dekat there exists a solution saja. Solution dekat mana? Dekat dalam A and B. Okay, so for a continuous function fx in the interval A to B, if FA times FB is negative, then there exists a solution or a root in A, IBT. That is the first thing. Second thing adalah bisection tadilah. Okay, I have highlighted the common mistake yang student buat. Satunya common mistake adalah tak tulis jawapan akhir. Okay, so please remember, highlight, you need to write down what is your final answer, what is your X, and X should be approximated to the latest C, bukan A, bukan B, bukan FA, bukan FC, should be approximated to C. Okay, so write down your final answer. And of course, the algorithm, kena make sure ingat or understand the concept dia yang saya cerita graphically tadilah, in order to choose which one need to be changed in the iteration process. A change ke B change? Change ke mana? Change ke value of C yang currently kita kira. Okay, so that's the bisection method. Ada apa nak tanya? Boleh faham tak? And okay.
Boleh, Doktor.
Yeah. So far so good. So again, solution, equation normally yang kita bagi, okay, basically can be obtained by the calculator at the first place. Okay, so whenever you have the bisection problem, use your calculator at the first place to get the answer, so that you have in mind, okay, what is supposed to be, okay, your guideline lah, so that bila you makin banyak iteration, you menuju ke jawapan yang you dapat from your calculator. Okay, so boleh dapat kalau dia bagi polynomial degree up to 4, boleh dapatlah from the calculator. Okay, kalau dia bagi fraction macam tu, dan mungkin tak dapat jugalah from the calculator. Okay, so if you look at the example yang you ada tadi, basically it can be obtained by the calculator at the first place. Okay, so boleh guna itu jugalah sebagai tips dia in the test. Okay, boleh. Yes, so if you don't have anything, I think that's all for now. Okay, see you in the next class lah. Okay, boleh. Okay, so till then, bye-bye. Assalamualaikum.
Thank you so much, Doktor. Thank you, Doktor.
Right, no problem.
Thank you, Doctor.